Standardizing all buildings under 100,000 square feet to 208 volts depends on several factors. These include the specific application, the local electrical code, and the cost of materials and labor. Let's consider the advantages. Firstly, higher power handling capacity. 208 volts can provide more power than 120 volts. This is beneficial for larger buildings or those with heavy electrical loads. Secondly, reduced voltage drop. Voltage drop is the decrease in voltage that occurs when current flows through a conductor. 208 volts has a lower voltage drop than 120 volts. This can help ensure that appliances and equipment receive the correct voltage. Thirdly, increased efficiency. 208 volts motors and appliances can operate more efficiently than 120 volts equivalents, resulting in lower energy consumption. Now let's look at the disadvantages. Firstly, higher cost. 208 volts wiring and equipment can be more expensive than 120 volts counterparts. Secondly, potential safety hazards. 208 volts is a higher voltage than 120 volts, so there is a greater risk of electrical shock and injury. Thirdly, limited availability. 208 volts is not as widely available as 120 volts. It may be difficult to find compatible appliances and equipment in some areas. The local electrical code will typically specify the minimum voltage that can be used for different types of buildings and applications. It is important to ensure that any proposed 208 volt standard complies with the local code. The cost of materials and labor can also impact the decision. 208 volts wiring and equipment can be more expensive than 120 volts, but the potential energy savings and increased efficiency may offset these costs over time. Whether or not it is reasonable to standardize all buildings under 100,000 square feet to 208 volts depends on the specific circumstances. It is important to consider the advantages and disadvantages, as well as the local codes and cost factors, before making a decision.